Phospholipase A2, or PLA2, is an enzyme found throughout the animal kingdom in venoms from snakes, scorpions, arachnids, and wasps. It is also found in bacteria and mammalian tissue, pancreatic secretions, and arthritic synovial fluid. Phospholipases are enzymes that hydrolyze glycerophospholipids. The group that which a phospholipase belongs to depends on the site at which a glycerophospholipid is cleaved. PLA2 primarily affects the phospholipid membranes of cells in the site of administration by cleaving at the SN2 site of the glycerophospholipid. The three major families of phospholipase A2 include secreted phospholipases A2, cytosolic phospholipases A2, and lipoprotein-associated phospholipases A2. Secreted phospholipases A2 is the family found in venom. They are characterized by a low molecular weight, approximately 13 to 15 kilodaltons, and contains histidine in the catalytic site, calcium 2+ bound in the active site, as well as 6 conserved disulfide bonds with 1 or 2 variable disulfide bonds. Extracellular phospholipase A2 is introduced to the body primarily by injection due to a snake or insect bite. Absorption occurs in the interstitial space, the extracellular matrix, and by the blood and lymphatic capillaries, depending on the physicochemical properties of the venom's component molecules. The venom which contains PLA2 interacts with the hyaluronic acid in the extracellular matrix and enters the blood vessels, causing localized damage to the vascular endothelium, which further causes the absorption characteristics of damaged vessels to change. Large molecules are absorbed primarily via the lymphatic system. Smaller toxins are directly absorbed into the blood capillaries. Toxins absorbed via the lymphatic system will have a different toxicokinetic profile from toxins absorbed into the bloodstream. Since PLA2 is a small type of molecule, it is directly absorbed into the blood capillaries. Once the venom is administered, all components, including PLA2, interact with hyaluronic acid, a component of the mammalian extracellular matrix and interstitial fluid. This facilitates its distribution throughout the site of administration. The bloodstream is the primary transportation for PLA2 and other venom components. PLA2 can successfully diffuse into tissues in order to interact with cellular membranes and acetylcholine receptors. The primary mechanism by which all venom components, including PLA2, are broken down in the body is via interaction with an administered antivenom. Antivenom is composed of several types of antibodies which specifically bind to molecules in venom. Antivenom is administered intravenously in order to force venom component molecules to release from receptor sites and deactivate them. This occurs because the antivenom has a high affinity for the venom molecules and not the receptor site. The antivenom binds to the venom molecules bound to the receptor site via a key-lock enzyme reaction. This causes the antibody-venom complex to release from the receptor as a whole and form a deactivated hydrophilic compound that is ready for excretion. If the venom component molecules are still mobile in the bloodstream, the same binding reaction occurs. Once the receptor sites are unblocked, they interact with acetylcholine as they normally should. This allows for voluntary muscle control and normal respiration to resume. Antivenoms are primarily derived by collecting antibodies from horses and other animals that have been subjected to a small amount of venom. The human body is capable of producing these antibodies as well, but since the fatal effects of venom take place faster than the rate of antibody production, antivenom is administered. PLA2 alone may be metabolized by the use of specific inhibitors and antibodies that are derived from plant and marine extracts.
created using Powtoon.